This is a little video about my Valiant I just restored. I took the panel and stripped it, repainted it, and got labels from Radio Daze. They made up a set of decals for me. They're commercially available now. In any case, the front panel is pretty much standard. I put some green LEDs in the back to make it light up a little bit better. They're pinball LEDs. Also, I made another change here, which I'll show you here. The left light was never connected to anything. I thought that was stupid. So I put bicolored LEDs in here. So these are green LEDs on both sides. And when you go to transmit, they turn red. Hard to see with the camera light being on. In any case, I did that. And I also got rid of the clipper. I saw no reason for that. So I used a hole for the clipper. And in that hole, I put the space to use. I put a bushing through there, didn't cut any more holes in the front panel, and I put one of those one of those eBay frequency counters in here. So now I can watch the VFO when I tune it and stay on frequency. I used to have a lot of drift in this thing. The drift was a problem. It drifted as much as 6 kc. Well, I found a bad microcapacitor in the VFO. That was part of my problem. But the other problem was heating. The 3 tubes up here, the driver tubes and all the rest of that for the oscillator and buffer, were generating a lot of heat. So I've put on them heat-sinking tube shields. I also added an aluminum bracket here, which is just pushed on. It's not screwed in, no new holes. And I just put the bracket on there to make an aluminum baffle to keep the heat away from the VFO. So that aluminum plate isolates it. Also, I put aluminum foil duct tape on both sides to reflect the heat and make it a good deal cooler. I might be able to show you how that all looks. Get my camera on here. I'm going to turn off the light. Okay. Calibrating all the time. But the tubes run a lot cooler than they used to. Where is it focused? In any case, you can actually see the reflection of the tubes in the aluminum foil. Oh, how can I get this focused? Hold on. There. That's focused. You can see the reflection in the aluminum foil for the tubes. And away we go. This tube in the middle, the 12AU7 is running a lot cooler than it used to. There was a 18K resistor on the cathode that had drifted down to 10K. In any case, enough of the camera. I also added modest ventilation holes in the top and along the sides. One of the other things I did is I sanded this door down. This door, if it's anodized, has a emissivity of 0.77. If it's sanded and like just bare aluminum, its emissivity is 0.07. So it's like 10 or 11 times less likely to absorb infrared heat radiation. I also added a regular incandescent light bulb to the top of the chassis. I always like to know that the power's on so I don't get ahead of myself. And then I added some resistors here to cut down some of the heat as recommended online. And of course with the 3 6146s, I tried to keep them as cool as possible, so I put nice big heat sinks on them. And the thumb screws are a plus. That helps. I noticed that the plate capacitor right here was not as big as it should be, so I added another one in parallel. It's supposed to be 2000 puff. So I did that. And also for protection for operator, I put ceramic caps on here instead of the old metal ones. Also in the audio section, all the tubes have heat sinks on them, which helps make everything run cool. You can see the bushing here for that frequency counter in there. I left the clipper transformer in there in case somebody in the future decides they wanted to put it back in. And then of course the 2 LEDs on the front panel are fed with a relay. So when I go to transmit, they turn red, and in standby it's green. So that works out pretty nicely. I also added one extra fuse out here for the high voltage transformer, so it's separate from the main fuse. That way I got a little more protection on the high voltage thing if I get a fault. I did have a fault, which blew out my meter. Had to get another meter. That was a bummer. So I've put a Schottky diode right across the back of this meter. The Schottky diode cuts in at a couple hundred millivolts, which is reasonable because the meter on full scale is about 80 millivolts. So anything much over that, the diode carries the current and protects the meter. A nice simple addition that you can put on there with no cosmetic impact. Anyway, cleaned the thing up, put it back together, got it running, and it's doing pretty good, pretty stable. And it's a lot cooler than it used to be, thermally. So there you have it. In any case, little paint looks good. Enjoy N4MQ.